Hello, everybody, and welcome to my first webcast. I'm doing about mod security and the core rule set. This is a new format, obviously. We have a cheesy intro, might be improving as we move along. And this is all a bit experimental. I played around with Open Broadcast Studio. It hated me, and I couldn't get this to work. So we're doing this on Zoom for a start. So this is like a meeting that you're attending every day. Anyway, so what is the plan with today, but generally? I want to share news, what is happening in the mod security core rule set world. So what's new, what is happening, what happened the last couple of weeks. I'm going to explain one or two technical things like news, insight, new rules, new problems, hints or tips, perhaps. And then I want to look at real world log files. What I see in my courses is very often that people have a hard time navigating log files. And this is where I think I can really bring expertise to the table, because I've been doing this for such a long time that I'm quite proficient when navigating log files. I found weaknesses and problems in log files very easily, and I want to share this with you. So there will always be a 5 or 10 minute deep dive into log file analysis. And then afterwards, we're going to do today, at least, we're going to do a brief demo with the CRS software that is used to handle false positive and how we access this. How do you get to the false positive in the end? And then links to future courses, publications, and so on. So let's dive in. What's new in the CRS and mod security world? If you followed the news, then you have probably seen that mod security did a new release. That was last week. Let's check this out. Let's go to GitHub of the mod security project. That is at Spider Labs mod security. So they have done a new release last Thursday. So tags, new release. There are still two release branches, so the 3.0 and the 2.9, and both saw a new release. This was relatively low key. This was not advertised as a security release, but what is actually happening, this is a security release. Let's check this out. So there were new features and impacting issues, and then a few bug fixes. Here, for example, it says there is a new collection. This is new variable. Multipart part headers. Multipart is when you do a file upload. So this is HTTP protocol. When you do file uploads via MIME headers and stuff. And there were weaknesses in the way this is being handled. And what they do now is they give us users, system administrator, rule writers, a new collection where we can inspect this further. Why is this necessary? This is necessary while a bounty hunter named Jerry Young, and he features here in several of these issues, discovered several weaknesses around this. If you know the MIME format, then you know it's really complicated. And he found several loopholes where he could trick the mod security MIME parser. So a file upload, or disguise your attack as a file upload, and then there is a loophole around, and suddenly the core rule set is no longer able to inspect your attack, while the backend server can perfectly read this attack or decode the attack. So we call this an impedance mismatch when the web application firewall and the backend server have a different MIME parser. They're reading different things. Mod security ignores the attack while the backend falls victim to the attack. And this happened, or this is possible via these MIME headers. I mean, there are a lot of MIME header rules around already in the recommended rules. For example, there are several rules around that protect you from these attacks. And this is a new class of attacks. And this came up in a big bug bounty program. So a big user of ModSecurity, one of the top 20 sites on the internet, today run a private bug bounty program on the core rule set, and in consequence also on ModSecurity in springtime. And this bounty hunter, Zhejiang, he discovered several weaknesses, namely around this multipart stuff. And they gave us this new collection that we can now write rules against. CRS, the core rule set team, is currently preparing a release to make use of this new collection to protect against these weaknesses. So here we have an attack that cannot be discovered by the core rule set, but first ModSecurity has to develop a new variable, this multipart headers, and then CRS will follow suit and create new rules. And the new rules are done, but we're in the testing phase. So in the next few days, you should see a new core rule set release as well that will then accompany the ModSecurity release from last week. Ideally, we would release together, but we were simply not ready. And apparently this multipart headers, that's a new thing, and writing stuff against new, it's not so easy. And there are additional issues that we're covering as well that are not affected by this ModSecurity release. So this bug bounty found quite a few weaknesses, also very critical weaknesses, and half of them, if you will, about half of them are covered in this new ModSecurity release, and the other ones will be covered in the core rule set release. So even if this is not dubbed a security release by the ModSecurity team, it is in fact a security release. And it's really important that you upgrade your servers in the 2.9 release line or the 3.0 release line. And here the first one says adjust parser activation rules in ModSecurity Conf recommended. You probably know this. If we go to the same URI, then we can look at the recommended rules. So these are rules that come with the ModSecurity project, and core rule set is based on these rules as well. So they're like, that's a few very important rules that ModSecurity recommends, and we recommend that you use them, because without them you lose a lot of protection. And they have updated this rule here. This is the XML, the SOAP rule that activates the XML parser. And this is the same for the JSON body processor. So these two. We're very close to this multi-part upload as well. It's about post request and how do we transmit post. Multi-part file upload is one way of doing a post request body. XML is another, JSON is another, and so on. And what they have changed here is this caret symbol. So it has a caret here and it has a caret here. Why is that? Before that, it was a regular expression that would say, if we have application JSON anywhere in the content type, then let's activate the JSON body processor. That makes sense. I mean, obviously it's application JSON, so let's run the JSON body processor. But the bug bounty hunters, of course, they found a way around this as well. And it's Zhejiang again. He was really, really active in this bug bounty. Great fellow, by the way. So he looked at this, I don't know how long, until he realized this is not anchored. And what he proceeded doing then was he would do the following. Show you an exploit now where you have the content type header here, and then it says application form URL encoded. So that is the MIME type upload, and then follows the boundary. If you're familiar with the format, here you usually have random text. The boundary is random text that is the boundary between different fields in this form encoded upload. And he would go, hey, my boundary is application JSON. That's as good as anything.
Folini che quello che va in giro sempre e direi anche oggi.
Could you mute yourself, please? I think this was Alessandro. The application JSON is a boundary as good as anything else. So let's use this. And of course, that gives us a hit on this rule. Without the caret, the boundary is taken as an instruction to use the JSON body processor. So suddenly he's using the JSON body processor and is no longer able to decode the different format, because the JSON body processor can only look at JSON. But what we're facing, in fact, is not JSON. So he was able to push this through, to bypass the correct body processor, and that means bypassing the whole core rule set. That means this is effectively a partial rule set bypass. This is a bypass of any rules that you're using for post request, for request bodies. Header attacks, phase one attacks, still not working, but anything around arguments, request body, you can now have a bypass. Very, very hard, very security net. That's really critical. That's why you really have to update, and not only update the binaries or the source code, you also have to update the recommended rules. So this rule and this rule. By the way, there is a further that is not so new, but this directive is also new in this release. This limits, no, the directive is not new, but it is new that it's in the recommended configuration. And you should, if you don't have this in your configuration, you need to add this to your configuration. This is a JSON parsing depth limit. If you're not having this, then you can have a very deeply nested JSON. An attacker can prepare especially crafted deeply nested JSON, and it goes really down until your server explodes. And this puts a limit on that. So that's the news here by the ModSecurity release team. And in the next couple of days, you will see a core rule set release that you also should apply. So update to the latest ModSecurity, please. Linux distribution packages are being backported as we speak. And then please update the core rule set as well once it comes out. We're going to release for the 3.3, that's our stable release branch, but also the second stable one, the 3.2. We're not going to update 3.1 and the 3.0, which are really legacy and not supported by the team anymore. You would have to backport yourself. And in the rule set, that is always possible, but it's work for you. It's probably better to look at upgrading. Okay, that's that. So now let's look at a log file. Next part of my webcast, let's look at log files. We're going to look at netnea.com log files every month now. That's what we're going to do. This is my company's website. You've probably seen it before. This is where I have my tutorials. This is where my teaching is based. So security courses are covered here. And a lot of people come to this website to look namely at these tutorials, introduction to embedding ModSecurity, including ModSecurity core rules, and so on. We have thousands and thousands of visitors every month looking at that. And now we're checking out the log file of this server. This is no critical data. There is no user, no money involved here. This is just a standard website with information. That's also why I can show you the production logs, because there's nothing really sensitive in it. Let's look at the access log. So in a month, we have 370,000 requests. And then let's check how many ModSecurity alerts we have, more or less. Wow, 20,000. Okay, that's quite a bit. I'm going to show you, let's give me the last line of the access log. This is the extended format. If you're familiar with my tutorials, I'm explaining this log format here. This is zooming down to somewhere up. I'm too far already. Somewhere up here. Here, this format is it. This is the format we're looking at. extended in the tutorial number 5. This is the last line. I have done a little bit of adoption. I have extended the GeoIP with the ASN, so the network code from the RIPE database. This is a new experiment that I'm doing. But here is the timestamp request line, refer, and then user agent, interesting stuff, the handler. Here we have unique ID, TLS protocols, IO in, IO out, duration. This request took half a second, fairly long request. And then here is all the CRS stuff, or here actually is the CRS stuff. Nothing, no alert on this request. And now I have a standard Logfile analysis script that I'm running here every month, and we're going to inspect the output of this. This takes quite a bit of time. It's a heavy thing, so I've done this previously, saved it, and now we're looking at it. Here you have the start and the end period. We have this 370,000 requests, and 96% of the requests are requests without an alert. So CRS did not complain. And then we have 1.5% of the requests where we don't have scores. How is that possible? That is possible if a client does a TCP SYN and then doesn't submit a request. You get an empty request. Or somebody trying out a different protocol on the HTTP port. This is how you end up without any scores. Without scores mean the request breaks before it hits core rule set. So that's why there are no scores. That 1%, that's reasonable. That's what you usually get. And then we have requests with alerts. Now it's getting interesting. We have 2% of the requests triggering alerts. Like 2% of the requests could be an attacker. They're probably attackers. They're security scanners scanning the internet. They're probably not targeting my tutorial website, but they're just scanning the whole internet for weaknesses. That is also what you can expect on a production server, like 1, 2, 3%, depending on the amount of your traffic. Let's say if you're reasonable traffic, then 2%, that's okay. And I blocked almost all of that. That means this is a well-tuned server. I don't have many false positive anymore. Actually, I'm always done with false positive on this service. I'm checking this from time to time, but I kind of know there is hardly anything anymore. Only 87 requests triggered an alert, went unblocked. Why? Because the limit was not extremely low. It was really low, but not so much. So the limit is at 3. If you're scoring 2 points, I think a numeric IP in the host header scores 2, you're not going to be blocked. But starting from 3, you're blocked. That is super strict. That is super strict. And then an interesting concept that you're probably not familiar with, but that is a new invention I made in spring, or a new concept I came up with in spring, is there are alerts that I'm interested in, and then there are alerts where I'm not interested in. And actually from the 7,700 blocked alerts, like 2,500 are not in. 2,500 of the requests are not interesting for me. I'm concentrating on these 4,000 or like roughly 5,000 relevant requests. Why is that? I don't want to be bothered by irrelevant stuff. And what is irrelevant stuff? Irrelevant stuff is stuff that is not targeting my application. And I'm able to determine this in an automatic way. Without configuring, I'm able to determine this out of the log files. I don't have the time to dig into this. If you're interested, get in touch. But I'm able to look at the log file and determine what is relevant and what is not relevant here. And almost all of this relevant stuff has been blocked. And here a bit more alerts, not so interesting. What is a visiting IP? I say a visiting IP is an IP that does more than 10 requests. That's very rough. But if you're just a security scanner pinging me, then you're not really visiting. I'm not interested in you. But I have like 9,000 individual IP addresses, that's like unique visitors visiting me. And almost all of them did relevant requests. The irrelevant requests are usually people scanning the internet for weaknesses, 1 or 2 requests per IP address. This is a typical website where very little interaction is happening. That's why we have so much get, very little post. On a standard production server, you usually have a bit more posts than this. You should have like 5%, 8% perhaps. It really depends. B2B side is maybe 10% posts. APIs tend to have much more posts. Here it's relatively low. And then what are the status codes? And this is a clean server, and you see this down here. We don't have any 500s. The application is really clean. There are no unknown issues, and nobody. The backend doesn't break from time to time. Doesn't happen. In a month, no 500. We cleaned this up a lot. We have kind of few 403s, seen this before, and then a bit of 404. That's across all requests, including the irrelevant stuff. So somebody scanning the internet is going to get a 404 because we simply don't have that application installed. Scan this server for Drupal and you're getting a 404 because there is no Drupal installed. By the way, it's a WordPress site, by the way. And then next information, IO in and out. So this is standard size. Out always the median and then the mean. So half of the requests are smaller than 7K, half of the responses are smaller, half of the responses are larger than 7.5K, and the mean is at 30K. Duration seems to be okay as well. We have a median duration of 11 milliseconds, so that's 11,000 microseconds. That's okay. I mean, that's relatively fast. Here we're looking at tags. And then here, the top ModSecurity rules on the relevant requests. And here is something interesting. Here we have 80 illegal header except char set. And that is a brand new rule. This is a nightly build from the core rule set. So this is a bleeding edge nightly build core rule set. And we have a new rule that says the except char set header is illegal. That header is deprecated. And servers are meant to ignore this for more than 10 years now. This is called a prohibited header. But as it happens, in this 300,000 requests here, we got 80 requests on a relevant URI with this illegal header. And we're blocking this now immediately. And that is new. I think it's a wee bit much. I inspected this a bit, and the user agent looked a bit funny, but it's relevant to the crisis. It's hard to tell. I think this is legitimate, and nobody should be using this char set header anymore. Maybe it's simply very old browsers, because all the modern browsers are not using this anymore. But I'm a wee bit weary. This is supposed to be in the new core rule set release, but the team might have to have a chat about this. I'm a bit weird about that. And then if you look at the entire server, all requests, you're getting these two rules. These are custom rules I did myself. This is, if you try to do a WordPress login on a URI that's not existing, because our WordPress has a different path prefix. So the standard script kiddie looking for WordPress login pages is going to fall. Trip here. They drop into this rule, and I block this immediately. I hate this. I don't want to see this, and so on. So there is a difference between the CRS rules on the relevant requests and all the requests, so including all the rest. And apparently that's far more. Here you have relatively few on the relevant requests. Good. Then status code, that's not so interesting. And then if you go further down, yeah, here, what do we have? 404s. Yes, this is one such unwanted URI. This is not existing, and we're not going to do this. And we don't have ads. And the Apple Touch pre-com icon is not around. And the well-known security TXT, yeah, that's legitimate. Nea should probably provide this file now. Then we're getting quite a few of these requests. I mean, that's one of these requests per day. And then this log report closes with giving a standard attack, or just an example attack session. That's a Swiss IP address, and it does the following. So it accesses here author pages, looks at WordPress JSON. Here it is 2 slashes. It's already a very bad sign. That doesn't look too good. And we're not using XML RPC here at all. And you see there is a lot of 403. So that's really attacking. By the way, it's attacking because it has two slashes. I have a custom rule on that. I don't like this. We don't have double slashes in your URIs. That's a copy paste or a script failure by the attacker. So that much on that. That is the log file. We're checking this out next month again. If we have changes, maybe something happened to this accept encoding header rule, and we get known or used to this log file and see how it changes and so on. What I'd like to show you now is we move over to the false positive. I told you this is really clean. I looked for false positives a lot. So there are hardly any false positives there anymore. But I did a Coral set upgrade this week on the latest nightly build, and I have a new false positive. How do I know? How do I know in these 20,000 ModSecurity alerts, how do I know that I have one additional false positive? I know this with the help of an analysis script that I've developed this summer. This is how I call it. I say, give me all the false positive for score 5 and higher. Then I'm passing the access log, the error log, and then a config file. What is in this config file? Yeah, let's clean this up. I'm showing you what do I have in this folder. Yeah, there are several config files. So there is a bit of standard configuration there, but also customizing. As I moved along with this service, I defined a few things. Hey, look, this is really not a false positive here. This is really an attack. Don't show it to me anymore. So the default configuration takes it pretty far, and then I weed out the rest by hand. And what is left now is really only the false positive. So I'm running this script now. Here I go. So 370K requests and so on. That was a bit quick. It is a series of filter that filters away now the access log and the alerts. So it starts with 300,000 requests. And then it takes only NEA, no filtering here. And then give me the anomaly scores 5 or above. So 370,000 requests are thrown away. We have 5,000 requests that scored 5 and above. That could be false positive. Likely attacks might be false positive. Next step, let's look at these relevant URIs. I explained that concept a bit. 1,000 of these requests are not for relevant requests. They go away. I'm not interested. Then going down here, and then we have a step where we say obvious attacks. What is an obvious attack? If you're doing a log4j attack, Jindy in your payload, Jindy in your user agent, that's obviously an attack. Jindy is not existing in user agents. So if you do that, then you're an attacker. That is this concept. And that is extremely powerful. That's a handful of strings. That's like a dozen strings, takes it down from 4,000 to 3,000. And then a few additional filtering steps, and I'm ending up with these 4 requests. It's 4 times the same IP address. I can let you on a secret. Last week, this was my IP address. So this is me. I triggered false positive by editing the website. I triggered these false positives. And now I already know this is a false positive, but if I didn't know it was me, I would have to inspect this by hand. And I can do so by hand, probably know my log report script that I can use to do rule exclusion, but we can also use our CRS software. So we have this new script that identifies the needle in the haystack, the remaining false positives amongst all the real attacks. That is the huge time saver. And then we go to, so here you have the same report. in HTML format with the same 4 requests down here. Editing WordPress, here you see the prefix, by the way. We've simply installed WordPress under /CMS. Very powerful move, because all these security scanners are not, they're stupid enough to not follow the redirect. That's already good enough to do this, to cut them off in a real installation. So here we have the output of the script, and then we either do this with the command line script, or we write the rule exclusion by hand, or we move into the CRS software. So this is how we have the dinosaur. Let's make these false positives extinct. This is the alert. This is the alert parser here. And it says the args content has a problem here. That is a new core set rule, the updated node validator keyword list that triggers here. That is a false positive, because I've been editing this page here, saving it, and it gave me a false positive. So I have to get rid of this, either by hand or I'm using this software. The advantage of this software is I don't need to be a ModSecurity expert. I mean, this is like a wizard guiding me through this. Here it does a proposal, like let's drop the entire rule. No, this is a bit harsh. I could drop it for this parameter. Yep, or let's go down to target. Yes, I like this a lot more. This looks good. So here is the URI. I've done a bit of investigation myself. I'm cutting this away by hand because I want to make this a bit wider. And then I'm giving this a 10,220, I think, is my next 10,220 is my next rule ID. As you know, they have to be, the rule IDs have to be unique. So here is the rule ID. This is the rule for the args content. Here is args content where this happened. And this I can now copy paste. I could also configure a webhook where I can submit this right into the CI/CD pipeline, and this generates a pull request for my deployment out of this. But an AI is a very simple site, so I'm doing this by hand. Copy paste, adding this to the configuration, and it's gone. I did this yesterday, so I'm not repeating this. This was simply a false positive from the weekend. Okay, that's it. Mostly. What else do I have to tell you? I'm scheduling a new online ModSecurity course, so I'm constantly teaching. I'm doing in-house courses. If you're interested, get in touch. Then we can do a course for your team, like a group of 10, 12 people in your team, in your company. Standard course or an extended, customize. I'm open to that. The next generic online intro course, introduction to web application firewall, ModSecurity, core rule set, is happening in the last November week, Monday, Tuesday, 28th, 29th of November. And that's going to be online. I still have slots in October and in November for in-house course if you're interested. So this was my first webcast, only been 4 minutes too long. Thank you very much for attending. I'm going to upload this to YouTube probably and send you the link afterwards, but this will probably wait until the CRS release is out. So take this as a bit of an inside information for people who really want to dig deep into ModSecurity, and thank you for attending. Goodbye.